There are many ways of sorting data and searching through it afterwards. This video is about the insertion sort. Insertion sort works like this. It always takes the next item from the unsorted list and then looks where to insert it in the sorted list. In my example, I'll be sorting cards, so we'll define that for cards which have the same number, clubs is smaller than diamonds, which is smaller than hearts, which is smaller than spades. Code for an insertion sort could look a bit like this. Now, this is only one way of coding it up. Of course, there are many ways of doing it. For example, you could do it in a much less destructive way by making a copy of the original list. Also, it's possible to sort arrays as well, but this example uses array lists. So you would start with the helper method, public static array list of cards, sort, which takes an array list of cards, which we'll call toSort. So this is a method that will take an array list and give one back. So first of all, you start by creating an array list of cards, which we'll call sorted, which is simply an empty array list. And that's where we'll put the list that is sorted as we create it. So you can start by adding the first item of toSort into the list sorted. So sorted.add toSort.remove 0. Then we do a while loop, which will happen as long as toSort has items in it, so its size is greater than 0. We'll make a little pointer integer called pause, which will start at 0. Then we'll have another while loop inside the outer loop, which says that while the position is smaller than sorted.size, so while we don't go off the end of the list, and while the item at that position is smaller than the first item in toSort, so while sorted.getPause.compare to toSort.getZero is smaller or equal to 0. So here the card class implements comparable, and it's always a good thing to do when you're searching and sorting. So while the pointer does not go off the end of the array and the item that is at that pointer's position is smaller than the first item in the toSort, increment the position pointer. Then once you're done with that loop, it will mean that the position pointer will point at the first position which holds an item in sorted that is greater than the next item in toSort. And so at that position, you want to add the first item of toSort and removing it from toSort so you don't place it twice. So you'll do sorted.add toSort.remove 0 in position pause. And then when the external while loop will finish, that means that all the items in toSort have been moved to sorted, and you can return the array list sorted. Let's run through an example of this quickly. So we'll start off with our list toSort, which will be already filled with cards in a random order. So then, following our code, the first thing we'll do is create an empty array list of cards called sorted. Then we simply move the first item of toSort to the list sorted, and that means that all the other elements will shuffle up. Then starts the while loop. We'll compare to see if the item at position pause, which in this case is 0, is smaller than the first item of toSort. It isn't, so pause will stay 0, and the inside while loop will end. So we'll move the first item of toSort to the first position of sorted, which means that all the rest of the list toSort will shuffle down one space. Then we start again. So we see if the item at position pause, which is 0, is smaller than the first item of toSort. It is, so we look at item in position 1. Is it smaller than the first item of toSort? Yes, it is, so we'll move up pause 1, and then there's no more items in sorted, so we'll take the first item of toSort and move it to sorted. Then the rest of toSort shuffles down, and we start again. So we take the first item of toSort, see if the first item in position 0 of sorted is smaller than the first item of toSort. It's not, so the inside while loop finishes right there, and we move the first item of to sort to the first position of sorted. Then for the 6 of spades, we look down to see where it fits in. It fits in between the 6 of hearts and the 7 of spades. So for the queen of clubs, we'll look, it's bigger than the 3 of spades, then the 6 of hearts, then the 6 of spades, then the 7 of spades, but it's smaller than the queen of diamonds, so that's where we insert it. And lastly, there's the 10 of hearts, which is greater than the 3 of spades, 6 of hearts, 6 of spades, 7 of spades, but not greater than the queen of clubs, so it goes between those two. And we're done. All the items of to sort have been moved to sorted. So the whole method ends after having returned sorted.